Hello and welcome again. My name is Dylan Turnbull. I am the DevRel at Brock.ai, and with me today I have the lovely and talented Dave, and Dave's going to show us our newest technology from Brock.ai, which is a tool called SlopCop. So with that, Dave, I'm going to go ahead and let you introduce yourself to the crowd. So give us a little bit of background on who you are, what you do at Brock.ai.
Cool. Yeah. So I was hired at Brock to essentially flesh out and implement a lot of the static analysis. So that is the tooling that analyzes the code, gives the LLMs a few ways to navigate the code base, look at things that something like grep can't really give you very easily, and up the speed and cost efficiency of our coding tasks and our coding agents. What my role has currently become is making a little bit more of the code review tools that SlopCop handles, but we'll get a bit more into that just now.
All right, excellent. So, I know we've been working on this for a few months now, and I'd like to hear a little bit about. I'm gonna mix things up a little bit, and tell me a little bit about what brought about the inspiration for SlopCop.
So when Ryan, another one of our colleagues, made the code review tool, I think it was really good at getting the important things out the way. So something like your security, a level of how well something's architected. But I think when it comes to jumping back in the code after a few agentic rounds of coding that could pass, again, agentic reviews, you can often not really. You get back to the code, you don't recognize it, and it's also increasingly more difficult to continue, whether with AI or not. Things get put all around the place, and the comments aren't really helpful. One issue we've had personally at Brock was failure handling that just kind of catches something and logs it, where you'd rather have that exception go a little bit higher up the chain. A lot of these are very LLM specific, and we wanted to have something that could smell these sort of code smells that LLMs specifically give off in code. And that's something that isn't really, hasn't been necessary until agentic coding became a lot more popular. And that was really a need driven by the sheer increasing production of code generated by AI, and how to manage it and maintain these code bases.
All right. So I guess the next bit would be maybe let's go ahead and have a look at SlopCop, if that's okay. Well, I'm gonna go ahead and turn on the user interface. This is the landing page of SlopCop, and if you would pretend I'm a new user and I've never seen SlopCop before, and just walk me through what the look and feel and the uses are for SlopCop.
Great. So the homepage gives you a little bit of a taste of what to expect. Quickly, if you want to scroll down, you also get a bit of a taste of some of the other features. But for more details on exactly how this works, we've got these detectives. Each one is going to be an agent that looks at your code, and it has a very specific role. For example, Detective Echo picks up the kind of code smell where LLMs typically re-implement a lot of small utility functions, something that already exists, but they often find it a bit easier to just recreate it in the same file, and you often get a lot of these duplicate code instances. Fallback describes the issue that I described earlier of really small catch blocks hiding errors. Maybe they'll just log something. Morg does dead code, etc. And so we have about 7 of these. And once we get hold of your repo, we run these guys. They each give a report individually, and then Lieutenant Case, right at the end, combines everything. So the way you get started, you press this button over here, and you'll get to the repo, the repository upload page. So far we support public, GitHub, GitLab, and Bitbucket URLs. And if you want a private scan, we currently support that for GitHub, and you would connect your account there. So let's
Now, is
connect
that just
our
using like a standard SSO connector, just like most other things that connect to GitHub
yeah, you just
for the private repos?
click on the link, authorize, can do it.
Okay, excellent. I would imagine I can see some use cases with this where if you're new to agentic development work, there's a I would say an array of users. There, everyone from the folks that we work with on a regular basis who are, veteran coders that are kind of working with AI as a way to kind of 5x, 10x their performance. And then there are those that are all the way to the other side of the spectrum, which is, full on vibe coding, which in that in and of itself produces an inordinate amount of slop on the internet. There's been no end of coverage of of the result of that endeavor. But I would imagine even if you're just a single developer working on a single project and you're working with AI, I could see this as essentially a way to almost like proofread your code. If you're unfamiliar, especially if you're not an experienced developer or you're only a junior developer and you just want a little more reassurance that you're not writing a bunch of garbage, something like this would be incredibly helpful as like a checkpoint, in my opinion.
Yeah, and I think one thing is that we don't expect users to take this as a shock of stop using AI. I think that isn't realistic. That kind of brings in also how part of the report is recommending what to do next and how to stop this kind of technical debt, this flavor of technical debt from coming back up. One thing we also do is that we keep the scans in the database. Obviously, you can delete your scans, but if a previous commit's detected, we reintegrate that summary into the new scans. And that should allow the report to also consider the progress you've made or the regressions you've made, and suggest what to do next.
Yeah, that tool in and of itself alone, I think, is worth its weight in gold. I mean, especially if you just kind of want to see. Let's say you were one of those people that jumped on the vibe code bandwagon a while ago, and now you're finally starting to get have that you're seeing the technical debt accrue, and you're starting to think, man, I really need to learn how this stuff works. And this is a good tool to be able to kind of peel back the layers, show you different things, give you some suggestions, and that like staged effect of here, run it once, get your report, make your updates, run it again, see if you're improving. And that may be just improved prompts. It may be doing your own code reviews without using AI, things of that nature. I think it in addition to being a good way to check your work, it's also an excellent. I see it as an excellent learning tool as well.
Okay, so I think let's paste our Swing application in the inspect report URLs section. So you'll see that we get some basic information to let you know that we did detect a valid repository, and the one that you're thinking of and that you did intend to paste in here. Then you select file warrant, and now you'll be taken to the scan. So one thing that you'll notice is we detect what kind of repository you have. So sometimes, it's not going to be code, and I think that's an edge case that we had to learn in production. But we currently support detecting, classifying a repository as ordinary code, the kind of thing we would expect. Documentation, say if you post a big pandas, I don't know, note-taking database repository, that's something that we'll classify accordingly. And also if it's just infrastructure, a bunch of YAML files, Kubernetes, Docker, that kind of stuff, GitOps. So that's an infra config, and that'll also have some agents we're currently working on. But the normal code one is our call detectives makeup. We give you a little bit of a taste of the static analysis in the screen. You'll sort of get a glimpse at the kind of files that are being seeded to our agents to look at. So some of these git smells, you'll sort of see with these tags over here, and they'll explain the kind of reasoning between why they're being flagged. This one specifically also has a bit of quite a high number of properties that our agents are going to look at. Then as you go down, you will see these agents are busy working. The lieutenant case is the report writing one, so that's not active yet. And you'll also see some debug logs. It's a bit more raw, but this is kind of precisely what the agents are doing. And this is all powered by the Brock agents and static analysis. So this kind of logging is something you'll see if you're running our tools, and it might look familiar if you have used our tools before.
And with the exception of case and the checkout, those two runs, those run first and last, but the rest of the agents will run simultaneously, right?
Yeah, the agents are sort of designed in a way that they have very specific tasks, sort of very singular and parallelizable. Everything's a read-only task, since this is a code review and not a dynamic code review. So by dynamic, I mean we're not running code, so there's nothing to do with race conditions or agents writes into the same file.
Yeah, well, that would make sense. I don't think there's gonna. I would be highly. That particular use case almost seems like a one that would be a tough nut to crack for just about anybody. I'm very excited to see what's going to happen. I've spent a number of years personally in my career working with Kubernetes since like the second KubeCon in Austin. And I'm very excited to see when we start integrating that capability, because I know that YAML sprawl is probably one of the biggest issues we had in that space. Even and now I bet it's like, probably 1,000x worse with the advent of AI. So
yeah, one thing I think that's quite interesting is seeing when the comment agent says, let me actually validate this comment, and it finds that, oh, the API is drifted, or the comment's drifted from the API. There's some sort of staleness. I've seen that come in a report as well. And I think some similar thing could probably happen with the sort of infrastructure, YAML, that kind of stuff. Maybe some versions of things no longer connect anymore as well as they used to, and the agent could know that. These are running the latest and greatest of Gemini models so far. But we are constantly benchmarking with GPT, for example, as what is going to be the best model between releases.
Right now, I thought I saw a recent post. I think that you just put up the blog where we were talking about 3.5 and how that's performing with SlopCop, right?
Yeah. The general trends we've seen up until now is that GPT has been really good at giving a lower slop score. It is a little bit more context aware and doesn't exaggerate or present big claims without evidence. One thing that we try to get one thing that we do is we funnel all the evidence, which is where in the code the agent is pointing to something, and then the claim. And one thing of Lieutenant Case, which is the synthesis, report synthesis round, handled by a larger model with high reasoning. Its job is to actually look at those links to the claims that are made and ensure that those are well founded. And I think when it comes to the Gemini models, they're a little bit more willing to overstate something on very little evidence. But one thing we did find with Gemini models is that they are fast and use our tools very well. And when we tested with Flash 3.5, we found out that it was quite disciplined in tool use and file reading. So the agents are able to call the tools that will point them to certain files. So that the tools are basically here to say, based on these heuristics, you should check out these files first. The GPT models, especially the minis, are very happy to read pretty much every file in the code base. But I think the Flash, what we saw in the benchmarks with the Flash models, and specifically 3.5, is that it is very good at using the static analysis tools and only checking the files that need to be checked based on that output. So we see a lot less token use and a lot fewer retries as well in terms of using the tools and also giving us the output we want in the correct shape. And despite it being 3 times more expensive than Flash 3 per token, we actually found that the total SlopCop scan cost was down, and it was the cheapest model because of how well it used the tools and how few tokens it actually consumed, given how few files it read, relative to some of the other models. And the quality didn't really drop. The evidence, rather, that it gathered was still good. It didn't come out empty-handed or say anything poor, but it is interesting to see how it'll progress as we benchmark other repositories and see what comes up in prod.
Yeah, and I mean, Flash 3 specifically has kind of had that hallmark of being fast, cheap, and relatively, as far as its ability to produce significantly decent output for the price and speed that it offers. That's interesting to see that they've continued that with 3.5. So
yeah, and in sort of a way that's the least obvious, since at face value you think you're going to be paying more, but when you put it in a harness setting, it's actually pretty cheap out of efficiency.
Excellent. Yeah, so one of the interesting things that one of our colleagues, Alex, added into the SlopCop site was this mini game Night Shift. I personally I've tried it, and I think I can't get past I think I've got 35 seconds or 30. I think it's 35 seconds is my big record. I think if you look at our current leaderboard, I'm WLD. But I see Alex's. So basically, tell the users what Night Shift actually is.
So scans can take pretty long depending on your repository size, and we have 2 ways of dealing with that. Either you give your email, and then it notifies you, and then we delete your email once the email's been sent. But if you're a little bit more active, like something to do, we have this mini game. There we go. So it's pretty basic. A little side scroller. Oh, but
yeah. When I was playing this, Alex said that the arrow keys you can push up to jump and then down to go down faster as well.
Yeah, sometimes you gotta go down a little bit faster to cue the next jump. He also recently
and I know he
added
in the power ups.
There we go. That one slows down.
that was fortunate timing.
Yeah.
Yeah, this is just a fun little thing. I think that is, allows you to pass the time. I know you can kind of rabbit hole this if you really want to see a score pop up. That's worth posting. I'm interested to see what as people start using this, what we'll see in the leaderboards. Because like I said, I think my top score is like 37 or 35 or something like that.
Alex got a minute. That's
a minute. Crazy. Wow. Geez. I find that, I've never been much of a side scroller guy. It kind of stresses me out, to be honest with you, but it's a fun little diversion, I think, just to pass the time when you're, like you said, when you're waiting for one of the scans to complete. All right. So let's check to see if the scan finished or not. It's got to be done by now.
Okay,
all right. Yeah. Looks like it did. All right. So walk us through what we've produced here.
So what we like to do is we want to put a number on things. So besides all the evidence and the actual useful stuff, I think to get a broad idea of how worried you should be about the mix between, do we think this is AI or do we think this is just messy code? That becomes a number, and in this case our repository is 66, which I think is pretty good for something where we do dog food our own AI tools against. Um, One thing that I think was a bit of a challenge is that how do we actually know something is written by AI? So off the bat, we start with some guesses. So for example, maintainability risk we say is high, but here the AI slop confidence is low. Sometimes when you see high and high, then you should be worried. This I think is pretty interesting, since historically this repository started with very little AI help. AI got a bit smarter. Then we got a little bit more bullish with using it, and then you sort of cycled back. But depending on who and what component, that was up to the developer at the time. But for the claims, apparently the evidence is strong, or at least the claims you are making. Here's some short, plausible, non-AI explanations. I see some text editing and some AST injection logic looks a little bit more human, like human debt versus AI debt. Some duplication across the analyzers. I can obviously have to own up to that one. That is just combining OOP and trying to redeploy and reuse the same analysis across various target languages. Here we get to the components that make up the score. This may or may not be equal to the number of the agents, since sometimes the agent is maybe not very confident. So that's sort of best effort to a degree. As we go down here, we get exactly what the agents would report to the reporting, the synthesis agents. So these are the specialist agents, and in this case, it's Flash 3.5. It's giving a short summary of what it found, the really important things, and then also gives an idea of sometimes where it looked. Some files it checked out. And as we scroll down further, we see the actual report that was then synthesized from these findings. Something that you kind of show someone to get a vibe of how bad things are. Well, at least that's what the executive summary does.
Okay.
If you're a little bit, I don't know, sort of suspicious about how we get to everything, and to actually be convinced that we looked at your code, a little background gives a little basic description of your code from what it found. Basically explains that the agent did look and understand what the application was. Also gave a bit of a methodology. This is maybe a bit more technical. And then we get to some of our findings. So here's some precise files linked to GitHub. So in this case, GitHub, if you upload GitLab or Bitbucket, it will be links from that. You have the exact files, and then you'll see some basic lines of code. Maybe it'll decide to highlight cyclomatic complexity or cognitive complexity, as per what the reason it was highlighted.
Okay.
You'll see some headers like duplication, where there's specific specialist flavored signals that were confirmed. As you can see, there's always a big emphasis of making some kind of claim, but also showing you which files these claims relate to. I also want to show you your non-findings, because maybe your code is really clean, and maybe your non-findings are bigger than your findings. So this is typically where a tool would have said something like, hey, we suspect something is in here. The agent goes and looks and then confirms, oh, that's a false positive or something like that, or this is maybe in the context of things not that bad. And here we get to the recommendations. So, this is the sort of now what do I do kind of section. So this isn't going to be necessarily an exhaustive list of how to fix your code, but at least for the high signal things, you've got a list of what to do and how to address the maintainability issues. Again, we don't expect you to do this manually, so we've got a prompt here. And let's go to this notepad. You'll see that it has a bit of a preamble, and then essentially tells your agent to create an order task list or plan, sort of enter plan mode. That's sort of the intent, to then go through these findings. And then, yeah, the idea after that is maybe in a couple of days, you can run another scan and see how it did.
Excellent. Yeah, that's. I think one of the things I wanted to point out, you use the word claim often, and I feel like that's a good way. An item that I think needs to be pointed out for folks is we are dealing with LLMs here, and LLMs you could ask most LLMs you could ask them the same thing, 2, 3, 4, 5 times, and you're going to get slightly different information back every single time. So, using this methodology is like a guideline and almost like a breadcrumb type scenario, rather than like it being a definitive action. So, because we are at the end of the day, the agents are written by us, the reports are constructed by us, but the LLMs are, where the logic comes from. So, that's why I think I just want to point that out to folks that this is not an exacting science, but it is a way to shine a much tighter beamed flashlight on things inside your repo that you might not otherwise see. So
yeah, and I think definitely also gives both you and the LLMs a bit of direction, and not just throwing magic at it and hoping that the LLM
fix everything.
Fix everything.
It's a much better prompt than that. Don't make any errors.
Yeah.
The ending of everybody's prompt.
Yeah.
So, and correct me if I'm wrong, but you can save all of this to a PDF, or you can print it if you want to read it, that sort of thing, correct?
Yeah, so you have the option to print it. I got a printer right over here. So this is what we looked at. I printed this in landscape, since that sort of matches the viewport. Obviously, it's up to you how you decide to export this. We could look at improving that and making that a little bit more specific to A4 pages, for example. But that's what we have right now. You can also copy it as Markdown. Again, something that you can just Control-C, Control-V. Gives you some of the fence JSON blocks that we also construct the evidence from. So you can also, if you have something that passes this, maybe your LLM would be able to reason about this better without all of this sort of CSS and the noise you'll see from a PDF. One thing,
and I could see creating your own, like an interesting idea might be, if you're going to use SlopCop on your repository, creating maybe an ongoing section of your documents to take readouts, take action based off of readouts from SlopCop, run another readout, and then just keep a historical, almost like repository-based line of improvements that you're making using SlopCop, and those various formats. Like I would most certainly not use PDF. I would use something, either the YAML or can we export to JSON as well, or is it just YAML?
Right now it's just Markdown with the JSON code blocks for the sort of
JSON. That's what I was thinking.
Fancy structures. Yeah, but we're one of the issues is having a feature request form. So feel free to submit any requests. Right now, this is SlopCop is in experimental phase in terms of getting the feature down. But I think if someone wants to put this in a CI pipeline, and you need some accounts, login, and linking GitHub repositories to some kind of cron job for scan. If there's interest for that, we can build that out.
Because right now there is no external like REST API that we could use, right?
Yeah, no, that's not available right now.
That would be an enhancement request for sure.
Yeah.
All right, excellent. Well, this is really cool. I think the next bit, what I'd like to talk a little bit about, and maybe to give the users some additional background as far as the journey to creating this prototype for SlopCop and getting it out to production. Tell me, what were some of the lessons learned that you that you came across during the process of creating this?
So I think there was a lot of trying to just throw the LM at it and see how far it can get. And I think a lot of the structure was figured out by the failures of the scans and the instability of LLMs, especially when it comes to large code. And one thing that we really had to do is get a benchmark suite running and have some kind of insight into the data and fine tune, and maybe find out that the models that we originally configured SlopCop with didn't actually give us great results, or the scans were just a lot of made up stuff that sounded good. And actually being able to add, for example, a sniff test that runs automatically to give us a live view into the quality of the code. So for example, we run like a big GPD model that scans all public repository scans, and for example, if a sniff comes in that's below some threshold, the sniff score based on a rubric similar to a SlopCop rubric, to make sure that the report is uses evidence, sounds good, is not overstated. If that quality is too low, I get an email, say, look, something in prod reads like crap, then I know to download the debugging, look at the public reports, and tweak the prompt a little bit, or tighten expectations. So I think, I guess the way to summarize that in plain English is just, this is a typical data science kind of problem where you need to gather data and just fine tune the whole time, and just that's kind of the loop. And what we ended up at is LMs need a lot of direction, and a lot of that direction was forged from the data we gathered.
All right, excellent. So, real quick, for the folks that are watching this video, SlopCop is publicly available now. You can go to slopcop.brock.ai, and then you can pick your repo, whether that's private or public. Scan the repo. You don't have to publish your results if you just want to pull the report or have it emailed to you and use it from there for your own purposes. That's lovely as well. If you want to share it with the community, or if you have a repo that you know is Slop and you wouldn't mind seeing it up on the most wanted wall, that's something that you can do as well. You can post it to the most wanted wall, and that way everyone can see whether something it has a high score or a low score on our most wanted wall. And with that, David, thank you so much for joining me today. I think it was incredibly informative for myself, as well as I'm sure for everyone else. And I appreciate you taking the time.
Yeah, great. Thanks for having me.